We are going to begin our lesson on properties of integer exponents by focusing on multiplication and division with exponents. So for a little review, an integer is a positive or negative number. It can't have any fractions involved with it or decimals involved. So an example, I put three numbers here: 4, -23, 194. So positive or negative numbers, no fractions, no decimals. And for another review, I have an addition problem and I have a subtraction problem. So I have 7 plus -3. So 7, you have 7, it's positive, and then you have a -3. So you're going to take 3 away from that 7. So we could rewrite that problem. A plus a negative is really a minus, so 7 minus 3. And our answer would be 4. The other way to think about it is 7 is positive, so you have $7. The 3 is negative, so you spent 3. How much do you have left? For our subtraction problem, we have 3 minus 9. So the 3 is positive, and the 9 is negative because of the minus sign. So if you wanted to, you could flip it around and make it 3 plus a -9. A plus a negative and a minus sign are interchangeable. So you have 3, but you need to spend 9. That's where the -9, you're spending it. So you have 3, you're trying to spend 9, you're going to need, so -$6 more. Okay, so little review for the adding and subtracting with negatives and integers there. So next, for the multiplication properties of exponents, here's our new part. We have to look at numbers with the same base. So this only works as if they have the same base. So first example, 3 squared times 3 to the 9th. They have a base of 3. So we can use this property to simplify this version. So if we think about this, 3 squared is really 3 times 3. And 3 to the 9th is 3 times 3 times 3, 9 times. 5, 6, 7, 8, 9. And we're multiplying in the middle, so another times there. How many 3's do we really have? If you count those all up, we have 11. So without having to write all of this right here, where did that 11 come from? Well, look at the exponents. How could I get 11 out of 2 and 9? Well, I just add them. So 3 to the 2nd plus the 9 is where the 11 comes in. So if you're multiplying with exponents and the bases are the same, you simply add the exponents. So add exponents for multiplication. All right, so this example, the t's, the bases are t's, and they are the same. And we have a -8 and we have a +12 that we need to add together. So think about the 8 as in owing $8 or wanting to spend $8. And the 12 is positive, so you have 12. So if you want to spend 8 and you have 12, you'll have 4 left over. So t to the 4th. This one's a little bit trickier. So the coefficients are the numbers out front. So the 2 and the 4, we can multiply those. 2 times 4 is 8. Because this is all multiplication, there's no adding or subtracting signs or division signs here. Everything's multiply. So 2 times 4 is 8. Then the x's, we have x squared times x. Well, if that x doesn't have an exponent, it's really a 1. There's one x there. So we're going to add those exponents. 2 plus 1 is 3. And then we're going to look at the y's. We have y to the 3rd times y to the 2nd. So 3 plus 2 is 5. So that can simplify down to 8, x to the 3rd, y to the 5th. And then we're going to move on to talk about division property of exponents. So I'm going to give you a minute to think about if it's multiplication, we add the exponents. So what do you think it's going to be if it's the division property? What are we going to do with our exponents? You guessed it, we're going to subtract them. So 5 to the 10th power, I'm just going to show you why we subtract, would mean that we have 10 5s out here. 7, 8, 9, and 10. And then 5 to the second at the bottom means 2 of them. What is 5 over 5? 5 divided by 5 is 1. What happens when we multiply by 1? Nothing changes. So basically, we can cancel out 5 and 5. So that's where the subtraction comes in. How many are left over? There's 8 of them up there. So 5 to the 8th power is our answer. So a quicker way than writing that all out would be just to think about the top number is 5 to the 10th. We have to subtract whatever is at the bottom for an exponent. So 10 minus 2 is 8. All right, this one, y to the negative third divided by y to the 6th. The bases are the same, so we can leave that. We have a y. We take the top exponent and we subtract the bottom exponent. So a negative 3 minus 6. So basically a negative 3 and a negative 6. So you owe both those numbers. So you're going to owe 9. And then this one looks a little bit different. This one has just an h. So again, at the bottom there, if there's not an exponent written, imagine there's a 1 there. Our bases are the same. Those are h's. Our top exponent is 7, and our bottom exponent is 1. So 7 minus 1 is 6. So h to the 6th.